Okay, so let's start. Write some questions, and the questions from your efficiency and yes. Okay मानिक, ये पर्सनली जो है रिकॉर्डेड का सेंड किया जा रहा है बच्चों को, ठीक है। जिनका भी छूट गया वो पर्सनली बोले उनको पर्सनली सेंड करूंगा, चलिए ठीक है। चलो क्वेश्चन बनाओ। फर्स्ट क्वेश्चन, राइट द क्वेश्चन। द AM इक्वेशन SAMT equal to 10 into 1 plus 0.5 cos of 2 pi into 10 to the power 4t into cos of 2 pi into 10 to the power 5t. This is the equation of AM. Find the efficiency, bandwidth, total sideband power, carrier power, total power. चलिए निकालिए। Find सब कुछ, find all parameters. Find all parameters. This is the singleton modulation, not the multi-ton modulations. This is your singleton modulations. Okay. Got it, my dear friends? So this is your singleton modulations. Now, what's the AC? What will be carrier power? PC equal to AC square by 2. Okay. Here we assume R equal to 1 ohm. So AC square by 2, and this is equal to 10 square by 2, and this is equal to 50 watt. Bandwidth is twice of FM. So this is your 2 pi FM equal to 2 pi into 10 to the power 4. So twice of FM is what? 2 into 10 to the power 4. This is 20 kilohertz. So bandwidth is 20 kilohertz. What is the total sideband power? What is the total sideband power? Total sideband power equal to PC into beta square by 2. So PC is what? This is 50 into beta square. Beta is 0.5. So this is 0.5 square divided by 2. And this is 50 into 1 by 8. This is 6.25 watt. Sorry, 25 watt. What the total power? Total power can be right here, PC plus total sideband power, and this PC equal to 50 watt plus 6.25 watt. This is 56.25 watt. This is the total power. Is it clear, my dear friends? Is it clear? Okay. Right, each everyone, clear or not? Okay, Vidhi. Thank you. Now, what is the envelope? Now I am talking about the envelope. So what do you mean by envelope? Okay, my dear friends. So envelope क्या है, इसके बारे में हम चर्चा करेंगे. Okay. So my dear friends, what is the envelope? Envelope क्या है? मान लिया this is your message signals. Let's say this is your message signals M of t. Let this message signal is sinusoidal message signals. So this is your A minimum and this is your A maximum. Amplitude maximum, this is amplitude minimum. Now, in the amplitude modulation, what is in the amplitude modulation? Amplitude of the message signal is varied according to your carrier signals. So this is your M of t, this is your t. Now let's say this is carrier signal, also your sinusoidal carrier signals. Carrier signal is also your sinusoidal. Let's say this is your carrier signals. This is your carrier signals. Okay. This is your carrier signals. Okay. Now what will happen actually? Output is what? Output is modulated. So carrier signal is modulated according to your message signals. So this looks like this is your envelope. This is your envelope. This is your envelope. Got it? Now this point is what? Maximum. This is A maximum. And now this point is what? Minimum. This is A minimum. So the maximum peak of the amplitude, A maximum equal to, this is carrier signal, let's say AC, AC minus AC, AC into 1 plus beta, and A minimum equal to AC into 1 minus beta, where beta is what? Modulation index, that is AM by AC. This is your beta. Bandwidth is twice of FM, Mohit. Twice of FM bandwidth. I have already derived. Bandwidth is twice of FM. Okay. So beta is called modulation index, and this is equal to AM by AC. So beta is AM by AC. Got it, my dear friends? Now, what will happen actually? So if case 1, if you write the case 1, first case, if beta is less than 1, that is under modulation. Now, what will happen in under modulation? So in the under modulations case, if beta is less than 1, then A maximum is what? Positive, and A minimum is also positive. So this is the case of beta less than 1, envelope detector output. So this is the envelope for beta less than equal to 1. Okay, less than 1, not equal to 1. This is less than 1 under modulation case. Got it, my dear friends? Is it clear? Please write each and every one. Clear or not? That's good, Vivek. Yes, Gaurav. So A maximum is also positive, A minimum is also positive. Now, case 2. If beta equal to 1, this is called critical modulation. This is called critical modulations. So what's the A maximum? A maximum is twice of AC, and A minimum is what? 0. So your waveform it looks like, after the resultant waveforms, it looks like this is the A maximum, So A minimum value is 0. A maximum value is twice of AC. So this is your resultant. This is your resultant. This is 0 minus twice of AC. This is plus twice of AC. So this is for critical modulations. A minimum is 0. Okay. Now case third. Case third. If beta greater than 1, this is called over-modulation. This is your over-modulation case. Now what will happen actually in over-modulation case? What will actually happen? In this case, what? A maximum is what? My dear friends, what is the A maximum? A maximum equal to AC into 1 plus beta. And A minimum is what? AC into 1 minus beta. So for beta greater than 1, this is your positive, but this becomes your negative. So what will actually happen here in this case? Your envelope is nothing but this is positive. Now this becomes negative sometimes. And this is positive, this is negative. So this is positive. And this is your envelope. अच्छे से बना लेना. This is your envelope. Okay. So A minimum is what? A minimum is negative. And A maximum is what? Positive. So this is called our modulation case. तो यहाँ पर देखिए A minimum जब नेगेटिव आ रहा है, इस नेगेटिव के कारण डीमॉड्यूलेशन बहुत कॉम्प्लेक्स हो जाता है. किसका? ओवर मॉड्यूलेशन के केस का. इसलिए हम लोग AM में जनरली यूज करते हैं लोग आइदर क्रिटिकल मॉड्यूलेशंस और अंडर मॉड्यूलेशंस. So generally we use under modulation case, not the over modulation case. Now, by using this equation, A max plus A mean is equal to twice of AC. So AC can be right here, A max plus A mean divided by 2. This is your AC. This is your AC. Okay. Now come to the point. Next question. The peak voltage of AM signal. Question right लिखे. The peak voltage of AM signal varies from 2 volt to 10 volt. Varies from 2 volt to 10 volt. Find modulation efficiency and total transmitted power. Find modulation efficiency and total transmitted power. Modulation efficiency and total transmission power. I mean what? You have to given what? A maximum 10 volt. A minimum 2 volt. So what the AC? A max plus A min divided by 2, this is 6 volt. So what's the carrier power PC? AC square by 2R, and this is 6 square by 2, this is 18 watt. Got it? Now what will happen? Beta, modulation index. So A maximum is equal to AC into 1 plus beta. Just put here, this is 10 equal to AC, and AC equal to 6, 1 plus beta. So here beta equal to 0.66. Beta equal to 0.66. Or the formula of beta is A max minus A min divided by A max plus A min. This is the formula of beta. Just put here, you will get the beta. So what's the total power transmitted? This is PT equal to PC 1 plus beta square by 2. And this is PC equal to what? 18 watt. 1 plus beta square 0.66 square divided by 2. And you will get the answer. This is 22 watt. What the modulation efficiency? This is beta square divided by 2 plus beta square. And this is 0.66 square upon 2 plus 0.66 square into 100. And this will be equal to around 18%. So efficiency will be around 18%. Got it, my dear friends? Is it clear? Is it clear? Okay. यस, एम में मोस्टली क्वेश्चन फॉर्मूला बेस्ड ही रहेंगे आपके. चलिए, नेक्स्ट आपको पढ़ाया था मैंने मल्टी टर्न मॉड्यूलेशंस. ओके, चलिए नेक्स्ट क्वेश्चन. दिस इज द क्वेश्चन ऑफ गेट फॉर द मल्टी टर्न मॉड्यूलेशंस. देखिए, ये कैरियर ऑफ सीटी इक्वल टू 20 cos 4 pi into 10 to power 60 is amplitude modulated by a message signal having frequency fm1 equal to 10 kilohertz, fm2 equal to 20 kilohertz, with modulation index beta 1 equal to 0.6 and beta 2 equal to 0.8 respectively. Find bandwidth, efficiency, total transmitted power, carrier power, and total sideband power, and modulation index beta t, bandwidth, efficiency, total power, सब कुछ, मतलब सभी पैरामीटर्स आप निकालिए. Got it, my dear friends? चलिए, beta t, bandwidth, efficiency, total transmitted power, PC, total sideband power. Yes. What is the beta t? Beta t. Under root beta 1 square plus beta 2 square. This is under root 0.6 square, 0.8 square. This is equal to 1. This is beta t. What's the bandwidth? Twice of f maximum. So f maximum is what? 10 kilohertz or 20 kilohertz? This is 20 kilohertz. So twice of 20 kilohertz, and this is 40 kilohertz. What's the efficiency? Beta t square upon 2 plus beta t square into 100, and this is equal to 33.33%. What's the carrier power? 20 square by 2, and this is equal to 200 watt. What's the total sideband power? What's the total power? This is PC 1 plus beta square by 2, and this is equal to 300 watt. Total power. So total power can be right here. Total sideband power plus carrier power. So total sideband power is what? 100 watt. Is it clear, my dear friends? Is it clear? What 11.11 is what? Efficiency. Beta t is 1 now. Efficiency will be 33.33%. Okay. Now, current relation in AM. Current relations in AM. असली कम्युनिकेशन मजा आएगा कब? जब हम आपको पढ़ाना शुरू करेंगे डिजिटल कम्युनिकेशन। उस समय आपको असली मजा आएगा कि कम्युनिकेशन कुछ पढ़ रहे हैं। बीट एरर रेट, बड़े बड़े प्रोबेबिलिटी के क्वेश्चन सब चुटकी में बनाएंगे आप, है ना। बहुत ही अच्छे तरीके से पढ़ाऊंगा, ठीक है। बड़े बड़े क्वेश्चन हम चुटकी में बनाएंगे। दिस इज करंट रिलेशन इज इन एएम। ओके, सो आपको पता है सर पीटी क्या होता है? पीटी इक्वल टू पीसी 1 प्लस बीटा स्क्वायर बाई 2। ओके, so this can be right here. Total current IT square into R equal to IC square into R 1 plus beta square by 2. So IT equal to IC under root 1 plus beta square by 2, where IT equal to total antenna current. Total antenna current. IC is carrier current, or this is called unmodulated current. Unmodulated current. Okay, got it? And this is called modulated current. Modulated current. So that's the difference between modulated and unmodulated current. So this is the current relationship in your AM. Same as it is voltage relationship is what? VT equal to VC 1 plus beta square by 2. Because as you know that power is directly proportional to current square, or power is directly proportional to the voltage square, where beta is what? Modulation index, and this is equal to what? AM by AC. Maximum amplitude of the message signal upon carrier signals. That AM by AC represent the modulation index. Is it clear, my dear friends? Yes, Sahil, beta is a modulation index. Now, this is the question from the IES prelims. The question is, an unmodulated AM transmitter current, IC equal to 5 ampere, then find IT with modulation index of 0.5. Then find IT with modulation index of 0.5. चलिए सॉल्व कीजिए. Is it clear, my dear friends? What is the formula? IT equal to IC under root 1 plus beta square by 2. This is the formula. What is the IT? IC is what? 5 ampere, right? This is 1 plus beta square. This is 0.5 square divided by 2. Just put here and you will get the answer. So what's the answer, my dear friends? This will be equal to 5.32 ampere. Right, second question. This is the question from the gate. An AM transmitter current is given by 10 ampere. An AM transmitter current is given by 10 ampere with 40% of modulation index. With 40% of modulation index. I mean, IT equal to 10 ampere when beta equal to what? 0.4. Find AM transmitter current when beta equal to 0.8. Find AM transmitter current when beta equal to 0.8. Solve it. What is the formula? Just formula लगाइए आप. क्या होगा? IT equal to IC क्या होगा बुआ? 1 plus beta square by 2. यहाँ पर देखिए बीटा जब 0.4 था तो IT कितना था? 10. So IC कितना हो जाएगा? 10 upon under root 1 plus 0.4 square divided by 2. And you will get the IC equal to, this is 9.6 ampere. Now what's the IT when beta equal to what? 0.8. So just put here IT equal to 9.6 under root 1 plus 0.8 square divided by 2, and you will get the 11.05 ampere. This is your answer. Got it, my dear friends? Is it clear? So these are the some basic types of numericals from the basic of AM, and I have already discussed what is the spectrum and how you can draw the spectrum. If anyone missing the class, then just WhatsApp me personally I will give you link and you can just watch the previous lecture. Okay, chali. Now I'm going to discuss what are the method which you use to generation of the AM. Okay, and how you can generate the AM signals. So in GATE exam, if you're writing the GATE exam or if you're writing the IES prelims exam, then just remember the names of the generation of the AM signals. In what way you can generate the AM signals. But if you're writing the IES mains, then you have to just know how you can generate the AM signals. Okay, so derivations part also comes in your IES mains. Okay, my dear friends. So I am going to discuss the next topic, that is the generation of AM signals. Generation of AM signal. That is how you can generate the AM signal. Is it clear? Is it clear, my dear friends? अभी तक जो भी पढ़ाया था क्लियर है सबको? Please write each and every one. Clear or not? Is it clear, my dear friends? Somik, Sahil, Mohit, Manik. Is it clear, everyone? So how you can generate the signals? That is a generation of AM signals. Okay, to generate the AM signal, basically there are two methods. First one is a square law modulator. And second one, switching modulator. अब देखिए गेट में कैसा आता है क्वेश्चन. गेट में आपको मैचिंग करने का आ जाएगा, है ना. जनरेशन ऑफ एएम सिग्नल बाय स्क्वायर लॉ मॉड्यूलेटर, स्विचिंग मॉड्यूलेटर, बोथ ए एंड बी, स्क्वायर लॉ एंड स्विचिंग मॉड्यूलेटर. ओके, बट कैसे जनरेट किया जाता है, दिस इज द पार्ट ऑफ योर आईईएस मेंस. गॉट इट. एंड गेट में अगर डेप्थ के क्वेश्चन आएंगे तो इसका डायरेक्ट जो इक्वेशन अभी हम ड्राइव करेंगे, उस ड्राइव किया हुआ इक्वेशन से आपका आ जाएगा. ठीक है, तो ओवरऑल क्या है कि पूरा डिटेल में आपको पढ़ना है दोस्त. तो सबसे पहले देखेंगे हम स्क्वायर लॉ मॉड्यूलेटर. स्क्वायर लॉ मॉड्यूलेटर से हम कैसे यूज करेंगे, एएम सिग्नल को कैसे जनरेट करेंगे, इसको देखते हैं हम लोग. Let this is m of t message signals and this is added with your carrier signals c of t. And this is your square law device. And the output each passes through the band pass filter and you will get the AM signal. So this is the basic block diagram of a square law modulators. Now, this is V0, this is Vi. So in the square law device, V0 is related with the Vi and this is equal to A0 times of Vi plus A1 times of Vi square plus A2 times of Vi cube dot. Where A0, A1, A2 are constant value. Now, what's the Vi? Vi is what? Mt and Ct summation. So M of t plus C of t. This is your Vi. M of t plus C of t. This is your Vi. So Vi can be right here M of t plus AC into cos of omega Ct. Now this input voltage is passes through through this square law device, and the output will passes through the band pass filter, and you will get the AM sequence. Got it, my dear friends? What's the band pass filter? This is your band pass filter, that is particular band of frequencies passes. Let's say this is FC. This is FC plus W, FC minus W. This is minus FC. This is minus FC plus W, minus FC minus W. Got it, my dear friends? This is 2W bandwidth. Okay. So now a square law device. So this is up to a square law. Square law, it means up to what? VI square. Up to VI square. Now log in with the second ID. Log in with the second ID, my dear friends. So V0 equal to A0 times of VI plus A1 times of VI square. So I will go up to VI square, not the VI cube, because this is a square law. So up to a square device. So V0 will be A0 times of VI plus A1 times of VI square, where VI equal to what? M of t plus AC into cos of omega Ct. Just put here. Just put here. Okay, got it? Now log in with the second ID.